So here we are going to walk through the code that I just showed you. And down here we have the registers and the value on each of them. As we are going through this code, it is going to be updated. And some of these, like base and temp, are not actually on Mars, but it's just shown here and named as such because you can basically kind of know what is the content of this all the time. So it's more clear. And here we have the memories. So on your memory, we are defining that str. So that's our label, and we have 6 elements, and we are initializing all of them with 0. So if you look at this, initially, before you run your code, there could be some content already in the memory that we are not necessarily knowing what is that. That's why it's written here as trash. And these are the addresses. So 6 bytes starting from here. You don't necessarily need to know this address because you're gonna use LA to load the address of the base. But if you have the first one, it's gonna usually start from this address. And let's do the walkthrough. So you see here, as soon as you run your basically initializing your array and you are setting to 0, all this content gonna be basically set to 0 for 6 elements that you have. So that's just initializing everything to 0. Then the next thing, you are going through your I and set 0 to I. So here I, we don't know what is that at that point, but after we run, we're gonna get that 0 there. The next thing, you are doing the hex value of A or 10 into your T1, and basically we see that's the change that we're gonna have. Then this is the important one, that we are doing LA, as in the load address, of str into base. So that's a direction. LA, address of str, so load address of str into base. And str, this label always refers to the first element. So that's how it always works. When you have a label, it could be so many elements, but you always, when you have the label, you are looking at the beginning of that address. So it's gonna be this address. So when we go to the next one, base becomes this address, which is the starting address for str. So what happens when we go through the loop? So every time we are adding base and I value, and we are saving that into temp. So currently temp, we don't know what is the content. It is the first time that we are running the loop. So after we run that, so we add I and base. So I is the element that we have. So you add a 0 element, so or first one, but the element 0, and that's going to be added to base, so we're going to get the same number. So basically temp here is our current element that we are looking at. So that's the idea of temp here. It's always like the current element that we are interested in. And then we are doing a store byte. We are doing a store byte of ti, so this is the content that we're going to write to our memory, and temp is basically showing where we are going to write in memory. So temp currently is at this address, so this is the location, and when we write that, we're gonna get this content to basically A. So that's basically writing to the first element. And then after that, we are incrementing I by 1. So here it's become 1, and then we are checking if I is less than 6. Well, I is 1 and it is less than 6, so we are jumping to loop. So we go back, and as you see here, it's the for loop and basically writing to the memory, but it's very mechanical, and that's how basically in MIPS you have to code. You have to do every step manually. So once we go back here, what would happen? We are adding I to the base, and base is not changed. So base is still this address, basically the beginning address, and actually there is a 0 missing here. That's the full number. And we are adding I to that. So we're gonna get basically adding 1 to this one, we're going to get this address. And that's going to be saved in temp. So after we go that, temp going to be ending with 1. So that's this one. And this is going to continue. We again store byte T1, which is not changing, it's still at A value, into temp. And now temp is at the second element. This address is that. So this becomes A. And then we are incrementing I. I will become 2. And then again we check. Is 2 less than 6? Yes. So we go to loop. So again here we are adding I to the base. So base is 0 and I is 2. So we're going to get this address now. So now our base is 002. And then same thing. We save that to this element, increment I, check, it is less, true, go back, basically incrementing base, adding I to base, so we get 3, saving the value 10 or hex to that address, this becomes A, increment I, check, it is still less than 6, we go back, increment base, basically adding I and base, save that value to the current location that temp is pointing to. So this becomes A, add I, so it's 5. Is it less? It is true. So go back. So again, we are adding I and base. So I was 5 and base was this one. So we get 0.5. Save that value to the pointer. So we get A here. Now here we add one more. So this becomes 6. Now is 6 less than 6? False. So that's going to be end of this loop. And we're going to continue. So basically that's how, like a whole walkthrough of this code. And you see that the main thing here is, well, one is the loop that you have seen before. And the other one is this LA and adding and the save byte. So basically how to get that first address every time you calculate the pointer, and then every time you use that register that is holding the pointer to update or read value if you want to.